Let's think through what would have happened on the querier if the server had responded with bad cookie. We actually know all the pieces to this puzzle from the previous slides. The query response has bad cookie in it. That arrives at the querier. The querier looks at it and he's frustrated because he actually wants a response. So in other words, in this case, it came back to the querier, and it was one of the cases where it wasn't spoofed. It was the client IP address had been the real querier. He had really sent that, and now he gets back bad cookie. What does he do? He queries again. Exact same query, but this time with the valid server cookie. That arrives at the server. The server sees the valid server cookie and now sends a normal query response, and the querier gets his answer. If bad cookie had arrived at a client whose IP address had been spoofed, then there wouldn't have been a second query. That computer that had never made the original query but had been spoofed would have simply thrown the data out because he didn't ask for that. Okay, let's dig into dig. So here we have a chance to see how cookies look on the wire in a normal DNS message. So we're going to run dig here, and we've thrown in a couple options that you probably don't normally use. No CMD and no question, plus no CMD and plus no QU is no question. That's turning off 2 of the 7 sections of dig output. CMD repeats back the command you asked. QU shows the question, the query that you sent. We don't need that for what we're doing. We're sending to a recursive server, then we should send with recursion. But we're sending this server here, ns4.tidelock.de, I know is an authoritative server. It will not do recursion for us. And to be polite, we will tell it we do not want it to do recursion. No REC, no recursion. That means we will send with the RD flag equal to 0, the RD flag cleared. And we are going to look up the domain name DNS Workshop, and since DNSworkshop.org, and since we have not specified the record type, we're looking up an A record. Great. We get a response, and that response in the additional section includes a EDNS, OPT record, and that has a cookie option. And this cookie is a server cookie based on the client's IP, based on the client's cookie, and based on the server's secret. This server cookie was generated. It came back. Dig, the client, looked at it, checked if it contained its original client cookie, which is the beginning part here. We'll see that in the next slide. And it says, oh, it's good. Now, a normal client would store this server cookie, but dig is not a normal client. Dig ran and it's ended. So it's going to be a different story the next time it runs. In fact, even to send this one query, dig had to generate its own secret. Okay, so that idea of generating its own secret actually makes things a bit strange when looking at server cookies with dig. So here we're going to run the same dig command once at the top, twice at the bottom, same command. We don't want any of the output sections. We're throwing away all 7 of them. And then we're turning on one of the 7 back on, called the comment section. That will allow us to see the EDNS output. And other than that, the query is identical. And here we send this query and we get this server cookie back. And dig tells us it's valid based on its own client cookie. And then we send the exact same query right afterwards. We get a different server cookie back. Yeah? And dig says again, it's perfectly good. And the reason that these are not the same, it's because dig used a different client cookie in both cases, and dig did not send a server cookie. A normal client querying the same server for a second time will have a server cookie to send. But dig does not save state, so it ended. And when it sent the new one, there was no server cookie to send, and it used a new client cookie. In fact, the client cookie is the beginning part of the record here and here. We can see that by adding to the previous dig the option plus QR. So dig normally only shows the response, but here we're going to also ask for the query we sent. Show me the query I am sending. So here under the top sending, we see in the pseudo section a cookie. This is much shorter. This is the client cookie that is being sent. Based on that client cookie, and if you did this over and over again, the client cookie will be different each time, special to dig. And based on this client cookie and the IP address of the client and on the server's secret, the server generated this server cookie, and part of that right up to here, 46325, is the client cookie. So the client sees itself and says, ah, that's valid. Yeah, that's why it keeps saying good, good, good. Dig has 3 options specifically related to cookies. There are other options, such as the eDNS options, that would also play a role, but let's look at the specific cookie options. Cookie support has been available in dig since bind 9.10.3, but beginning with bind 9.11, dig sends the cookie by default. Okay, 3 options. The first one, plus cookie. It's on by default. That just tells dig, send the cookie, which means it needs a secret. And because dig doesn't save the secret from last time, it generates a random secret each time, which means the client cookie every single time, even to the same server, is going to be different. Plus cookie, on by default. Turn it off with plus no cookie. Second option, what should dig do if a server responds with bad cookie? Well, the default is plus bad cookie, meaning requery. Requery until you get an answer. Requery sending the server cookie a second time. And that should make total sense for anybody familiar with dig, because dig always works its way to a final answer. For example, if it gets a CNAME response, it queries for that CNAME, it queries again, and it follows, let's say, a chain of CNAMEs or DNAMEs, etc., until it gets a final response. So by default, if it gets bad cookie, it follows through until it gets a response. If you do not want to requery, should the response code be bad cookie, plus no bad cookie. And the final option lets you explicitly send a cookie, either a server cookie or a client cookie, and then say plus cookie equals, and you have to provide a validly formatted cookie. So here's a dig up above, and with the grep command, we grab the valid cookie. And now we're going to use some of those options. Dig, actually output is, we don't want any output except the comment. We're not showing the output yet here. I'm going to say dig, no bad cookie. If you get a bad cookie back, don't requery. And then we're going to send a bad cookie. How do we know it's a bad cookie? Because here's a good cookie. This is what the server's expecting. And we're sending a server cookie. This is nice and long. This is the same length as up here. That's a server cookie. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, repeated 3 times is not the valid server cookie. So we're sending a bad cookie for the server, a bad server cookie, and we're saying don't requery. Okay. So now let's think about it. We're sending to this bind server a bad cookie, and we're telling dig not to requery. Is the server going to respond with bad cookie? Now, we have enough information. By default, is it going to respond with bad cookie? We have enough information that you can answer this question. If you want to stop the podcast and go back, you can do that. If not, we're going to go on to the next slide. So if you've answered the question, we're going to go on and see the answer. No. the server didn't respond with response code equals bad cookie. There it is. Status, no error. Under here we see the answer. There was an answer sent back. Why? That's the next question. Yeah, so it didn't respond with bad cookie. Why? You could stop and think about that again, and we'll look at that on the next slide. So even though we said, hey, here's a bad cookie, don't requery if you get a bad cookie, he didn't get a bad cookie. He got a perfectly valid answer. Why? Because we sent it to a bind server with the default configuration. The server, when it got the bad cookie, by default, simply responded normally, normal answer, but included the client cookie and a newly generated server cookie based on that client cookie. It would have taken extra configuration in bind to get it to respond with bad cookie. We'll look at that right after this. So dig here is reporting back that new server cookie that was generated based on the client cookie, which is sort of an interesting situation. If you are only working with dig, if you're only working with a querying tool, you are never ever going to see a bad cookie response, because bad cookie response from a bind server from named requires explicit configuration. Well, let's look at a server with that explicit configuration. Different server here. This was done in the lab environment of our courses, and we set up one of the servers to respond with bad cookie. And here we send a dig, and we say, do not requery if it is a bad cookie response, and we send that query to this server, 192.168.53.252. And that server's configured. If you don't get a valid server cookie, send bad cookie. What cookie does this dig send? Well, we didn't tell it cookie equals, so it sends a client cookie. What client cookie? Generates a random client secret based on its own IP address and the server IP address. Created the client cookie and included it, but it did not include a server cookie. So what do we get as a response, as a status? Bad cookie. What would dig have normally done? It normally would have requeried, sending back the valid server cookie from here, but we told it not to. Okay, that's enough of dig. Covers all the options. What about setting up cookies in named? We're into the home stretch here. Configuring cookies in named. Well, a couple things. First of all, named, if it receives a valid server cookie, regardless of configuration, shuts off features such as response rate limiting. Goes, oh, I don't need to slow things down. I know this is a non-spoofed IP address. Okay. Then named has 6 global configurations options that will go into the options block in named.conf. Some of them are more important than others, and we're going to cover them in the next slides. There are other options which would play a role as well, such as turning off EDNS. Not that that would be recommended, but those are not directly in focus. So this is the only major important option of the 6. Global options block, require-server-cookie, and then a boolean, meaning you can set it to true, for example. And if you set it to true or to yes, then it will respond with bad cookie unless there is a valid server cookie. But the default, as we have said over and over, is no. Other things you can do, you can set the cookie algorithm, which is unlikely that you're going to need to do that. You could explicitly set the cookie secret as opposed to having it generate one automatically. That is something you do need to do if this server shares its IP address with other servers. In other words, if it's part of an any-class cluster. Other than that, option you won't use either. The next options, no cookie UDP size. If the query does not contain any cookie, we can reduce the UDP response size. In fact, we can reduce it down below the original 512 byte UDP limit all the way down to 128 bytes. The default is the maximum that's allowed with extended DNS, which is over UDP, which is 4096 bytes. This is an option looking toward the future. If many years from now, cookies are widely used, then someone trying to spoof an IP address is going to have a problem. Well, one thing that they could do is they can send the query without any cookie in it, saying, oh, I don't support cookies. And then cookies have no effect. Except here, we can say, oh, no cookie at all? That is probably spoofing. If this is some future where almost all clients and all servers are using cookies, then we can say, there's no cookie at all. I'm going to make sure he cannot get any amplification out of a response. I'm going to reduce my response size to a very, very small size. 512 bytes, 128 bytes. For the moment, for the time being, I would not be using this option unless it's internal and you know you have all your clients and already using a cookie option. But for the future, it looks very option. Then the option send cookie, which you could turn off. The default is yes, meaning the default by named is it will send back a server cookie. This option really exists for resolvers, RDNS servers, and you can use it globally or separately for a specific server, and it is there to fix broken servers that are not properly handling cookies. Yeah. So if you're sending to a specific authoritative server that is simply barfing and completely not responding to cookies, normally this is because it is sitting behind a very unhealthily designed firewall that thinks it's doing smart things by looking deeply into the DNS header and saying, oh, there's an option I don't know, this is an attack. In that case, you can turn off sending cookies, but you don't want to do that unless you're having a specific problem. To sum it up, DNS cookies are a rather new, modern security solution in DNS. Considered a lightweight solution because they require very little configuration. They require no state being stored on the server. And it's simply a new option in eDNS. They provide protection for queriers from getting a spoofed response, which protects the domain name owner from his name being misused, being misrepresented. DNS cookies, when server cookies are fully configured so that the server responds with bad cookie when there is not a server cookie in the query. Also protect innocent victims in the case of reflection attacks. And the DNS servers themselves are then protected from denial of service attacks. Not bad for something so simple. Thank you for watching this video on DNS cookies. If you're interested in our training, the URL menandmice.com/training is on the screen. Hopefully I or one of the other instructors will be able to greet you at one of the upcoming courses. Perhaps I'll see you in September in Toronto.